SwayamPrabha. Digital India. Educated India.
Hello and welcome to the 5th lecture of the course on machining science. Let me remind you that in our earlier session, we have started discussing the tool nomenclature, and we said that different countries adopt different tool nomenclature, that means how to define the tool angles. And we have seen that in the American system or the coordinate system, it is the simplest one. That is, the basic coordinate system is used x, y, z, and within the x, y, z, taking the base plane, longitudinal plane and the transverse plane, the 6 angles and the tool nose radius are defined. Now, this is defined, as I said, in a certain sequence. All right. In case of ASA, the sequence is like this, as it is given here. There is a back rake, side rake, end cutting, end flank angle, side flank angle, end cutting edge angle, side cutting edge angle and the tool nose radius. So, mind it that what is the sequence means, that when the tool will be, if you take the tool which is in the ASA system, what you will find is, for example, here it can be written as 6 degree, okay, 5 degree. So, it can be 11 degree, or then it can be 12, for example, it can be 9, for example, and it can be 10, let us say, and the tool nose radius is 0.06. By the way, this is given in inch, okay, because it is an American system. So, the tool nose radius is given in inch, which is here. So, the tool will be defined only in this way, all right. And from here you have to understand that the first one is the back rake angle, second one is the side rake angle, and so on in this sequence as it is given in here. All right. So, if you purchase the tool, you will see that the tool specification will be given in this sequence, and you will not be told that which one is what. So, you have to know that in this sequence which one is the, for example, side flank angle, this is the side flank angle, this is the side rake angle, and so on. Okay. Then we have discussed the orthogonal rake system, and we said in the orthogonal rake system there are 3 mutually perpendicular planes that are used, which is the base plane and orthogonal plane and the cutting plane. These are the 3 planes which are used here. Now, for this you take the planes, one which is orthogonal plane, okay, another which is the cutting plane, and the third which is the plane perpendicular to the auxiliary cutting edge. So, these are the 3 planes in which you can show the angles, and the angles, as we said, that suppose if you take the cutting plane, and we said that the cutting plane is the plane which will contain the cutting edge. Okay. So, therefore, the view that you will be getting is like this, and it is not a sectional view, because this is the plane which will contain the cutting edge, and as if you are looking at the tool from this side, okay, perpendicular to this. So, we will have a view like this, and in this view, this is the rake face, and that rake face is making an angle I with the z axis, and the I is the tool inclination angle, as we said, or this is also called the angle of obliquity, because this is the characteristic feature of the oblique cutting, because the tool is inclined, and this is the tool inclination angle. Now, in here, this is the plane which is the orthogonal plane, all right. This is a perpendicular to the principal cutting edge, and in this view you will see that the rake plane is the flank plane, or the flank face is here. So, therefore, this rake face will make an angle perpendicular to the cutting velocity vector, which is the x axis actually. This is the angle which is called the orthogonal rake angle, and similarly this angle which is made by the flank face and the z axis, this is called the principal flank angle, Similarly, here you will have the tool inclination angle, and here you have the auxiliary flank angle. So, this is because it is in the auxiliary plane, all right, and this is the flank face which is making an angle with the z axis. This is the auxiliary flank angle. So, these are the 6 angles like in the case of the ASA system along with the tool nose radius, and in this sequence it is given. So, initially first it will be the inclination angle, then the orthogonal rake angle, then the principal flank angle, followed by auxiliary flank angle, auxiliary cutting edge angle, and the principal cutting edge angle, and finally the nose radius. Here the nose radius is given in millimeter normally. So, this is the sequence given in the tool nomenclature that is adopted by the continental or the orthogonal rake system, which is called the orthogonal rake system. So, these angles again will be different than the angles which we have determined in the case of the ASA. All right. These angles are different from these angles which are in the orthogonal rake system, because these angles are obtained in different planes, and in different planes the inclination will be different. So, the angles will be different, all right. Whereas, in case of the coordinate system it was a straight planes, that is the x, y, z. Here the planes are different. So, these angles are different from the one that we have obtained in the American system or ASA system. Next is another one which is called the international or normal rake system. So, this is called international because this is the system which all the countries are trying to adopt gradually. Okay. So, that all the tools, I mean from anywhere you purchase the tool, you can be it can be used in anywhere. Right now what is happening is that if you are purchasing a tool from the United States, you cannot straight away use it here, because you have to convert those angles into the angles that you have adopted in your country. That is, in India we are adopting the ORS, that is the orthogonal rake system. So, therefore, particularly when the tool is reground, when it has to be resharpened, for example, after the tool wears out, that we will discuss at a later stage, it has to be ground. Okay. So, during the grinding process the tool has to be placed in a particular way according to a particular angle. So, those angles are important, and we are adopting those angles as given in the ORS system. So, therefore, we have to convert those angles given by the ASA system, so that the tool can be ground properly. So, here in the international or normal rake system, this system is closer to the actual processing angles. By actual processing angle we mean to say the normal working angle when the tool is removing the material. Okay. So, at that time tool is interacting with the workpiece, at that time what are the actual angles that we are getting, this is more or less given in the normal rake system. So, here there are planes which are used. One is the base plane, this is the same as in case of the ASA or the ORS system. Okay. Another plane is the cutting plane. Cutting plane is the same as in case of ORS system. This cutting plane contains the cutting edge. Only thing is that this is the normal plane which is different than the planes taken in the ASA or the ORS system, and this normal plane is perpendicular to both of them, base plane and the cutting plane. So, these are the 3 mutually perpendicular planes in which the angles are given in the NRS system. NRS stands for the normal rake system. So, therefore, if we have the base plane here, in the base plane we will take the planes like this. One is the cutting plane. Okay. This was given like in case of the ORS. So, of course, this view will be same as in ORS. So, here we will have the rake face, and the rake face making an angle with the y axis. This will be the tool inclination angle. So, this remains the same as in case of the ORS. Next, here it will be the another plane that you are taking is the plane which is containing the auxiliary cutting edge. So, this is the view, okay, view of the plane which is containing the auxiliary cutting edge, we will call it as II. So, in this plane we will take another plane which is perpendicular to the cutting edge. This is the cutting edge, and EE is the perpendicular to the cutting edge. So, therefore, this is the plane which will be called as the auxiliary normal plane, because it is normal to the cutting edge. This is the auxiliary plane, okay, and this is normal to the auxiliary plane. Okay. Now, here it is this. In this plane, in this view, this is the CC, that is the cutting along the cutting plane. In this perpendicular to the cutting edge, again we will take another plane, and in this sectional view, because it is section, all right, in this sectional view, let us call it as NN. In the NN section, here what we see is the rake face here and the flank face here. So, therefore, this rake angle will be called as the normal rake angle, because it is again in a plane which is normal to the cutting edge, okay. And this angle which is between the flank face and the line here along the z plane, okay, along the z axis. So, this angle will be called as the principal normal flank angle. So, we have the angles like here we have the auxiliary normal rake and the auxiliary normal flank. Here we have the normal rake and the principal normal flank. Okay. So, these are the 4 angles. Fifth is the tool inclination angle, okay. And here we have the 2 cutting edge angles, one with the principal cutting edge which is called the principal cutting edge angle gamma p, and another along the along the auxiliary cutting edge and the x axis, which is called the auxiliary cutting edge angle. So, mind it, it is principal cutting edge here angle, here also we have given the principal cutting edge angle and the auxiliary cutting edge angle, which is the ORS. But in case of ASA system, as you can see, here it is not the principal cutting edge, but is 90 degree minus principal cutting edge. So, this is given in the ASA as the gamma s, and gamma s is the side cutting edge angle. Side cutting edge angle is 90 degree minus the principal cutting edge angle. So, this is the difference. So, here therefore, there are 2, one which you are having as the principal cutting edge angle. This is between the principal cutting edge and the x axis, and between the x axis and the auxiliary cutting edge is the auxiliary cutting edge angle. Now, rake angle can be defined with the 2 angles. Rake plane can be defined, or the inclination of the rake face can be defined by 2 angles. So, therefore, here this angle is redundant, all right. One of these angles, like for example, here we have the normal rake, okay. Here we have the inclination angle which is also the related to the rake face, and here we have the rake angle which is auxiliary normal rake angle. So, therefore, in the nomenclature the auxiliary normal rake angle is not taken, and the sequence given in the tool nomenclature adopted in the normal rake system, international or normal rake system, it is given in this sequence. Initially, first we have the inclination angle. This is actually the normal rake angle, it is not orthogonal rake angle. I am sorry, you can correct it. Okay. So, this is the normal rake angle, and then we have the principal flank angle, principal normal flank angle again, okay, normal flank angle. This is the auxiliary flank angle, this is the auxiliary cutting edge angle and the principal cutting edge angle. So, these are the 6 angles along with the tool nose radius, and here also the tool nose radius is given in millimeter because it is the international system. All right. So, these 6 angles plus the cutting tool nose radius, they are defined in the normal rake system in this particular sequence. So, once again, the tool when you are purchasing which is in the NRS system, the angles will be given like 0 or 6 degree, let us say, then it can be 8 degree, it can be 9 degree, it can be 10 degree, just an example 12 degree and 0.3 millimeter. Okay. Millimeter may not be written here, but you have to assume that this is the NRS system. So, the tool nose radius will be given in millimeter. If it is an ASA system, it will not be given in inch or something, but you have to assume that if it is the ASA system, at the end the tool nose radius will be given in inch. So, you have to always convert it into micron or millimeter. Okay. So, this is the sequence and you have to read it in the way that 0 means that 0 inclination angle, okay. 6 degree means the normal rake angle will be 6 degree and so on. This is the way. As I was telling initially that if we have one tool purchased from the ASA system for example and being used in the ORS system. So, these angles have to be converted because the tool has to be reground. Okay. So, this conversion as you can understand that this is not a very difficult one because if you combine these planes, that is the coordinate system planes and the orthogonal rake system planes, and in these planes if you show all those angles you can always relate them. Or for example, if you are converting the ORS system to NRS system, okay, then only you can actually convert it easily because you have to give in one system you have to give both those planes like ORS planes and the NRS planes. Let us take an example here. This is how the conversion can be made. Let us say this is the conversion from ORS to ASA, that is orthogonal rake system to American system, okay, coordinate system. So, let us look at this how we are combining these planes together. Let us say this is the base plane, okay, and in the base plane we will take sections CC, okay. This is the cutting plane as in case of the ORS or as in case of the NRS. Then we will take the YY as in case of coordinate system. We will take another plane XX as in case of coordinate system. So, we have the coordinate system x and y. Now, in the ORS we have taken CC and then we have to take another plane which will be perpendicular to the principal cutting edge, okay, which is the orthogonal plane, and we are taking this orthogonal plane, and within these planes that means we can show all those angles which are given in the coordinate system and the ORS system. Then we can correlate them together. So, this is what geometrically. So, this is what it is shown here, nothing very complicated. Now, let us say that in the CC this is given in here, okay. So, since this is the view, so it is not hatched and this view will be like this where we have the rake face here and this is the tool inclination angle as the tool is inclined, alright, and YY section is given here. So, this is the sectional view of YY where it is, this is the transverse plane as you understand that, XX is the longitudinal plane. So, in the transverse plane you have the rake face here, you have the flank face here. So, therefore, this angle will be the back rake angle as in case of the coordinate system, and this angle is the end flank angle as in case of the ORS, as in case of the the ASA system. So, this is the view along the YY section which is actually in the ASA system. Similarly, this view along the XX it will be in the ASA system, and this in this view sectional view this is the rake face, this is the flank face. So, therefore, this is the side flank angle and this is the side rake angle as in ASA and so on. So, similarly, like for example, if you look at the orthogonal OO. So, OO is given here. So, this is the orthogonal rake system or this is the orthogonal rake angle and this is the principal flank angle and so on. So, you can see that all the angles of the ORS here, of the ASA here and here, and the ORS in this view and in this view they are here. Now, if you can correlate them, then we can actually have the combination or the relationship between the angles from the ORS to ASA and vice versa ASA to ORS. Let us see how it can be done. Let us see tan I in this view, tan of this angle, okay, this is BC BC prime divided by AC and the AC prime, sorry, AC and the AC prime. So, it is given in here, okay. See, this is somehow AC and the BC prime, please correct it, this is the BC prime, okay. So, AC BC prime AC and the BC prime, this is actually equivalent to A and the B. All right. So, I will not go into all the details. What I will like to show you that how this conversion can be made in one example, then all other examples will be a similar one. So, this is simply a geometric conversion. That means, here what we are trying to show is that in this view, okay, if this is the tan I, so this can be correlate to the other planes, okay, all other planes. For example, here how we are doing that, as I said that AC and the BC prime, this is equivalent to A and the B, all right. So, this is, you understand. So, we are bringing the CC view, that means ORS or NRS. Right now what we are talking about is the ORS and the ASA. So, let us say in the ORS system what we have, this is the CC cutting plane, this we are relating or coming to the base plane now, and the base plane is common in the ASA, ORS and the NRS system. Okay. Similarly, BC prime here, that we are actually taking to the this view, okay, like that. As you understand that this can be done by taking two planes perpendicular, mutually perpendicular planes. You project these points here, and from here you take it to the other plane, and here there is also perpendicular to these lines, and then from here you can take it to the other planes, like this is the again the YY and the ASA system. Here also it is the ASA system. So, these points can be taken from here to here, and if you see them Tx 2 prime, for example, here we have taken it, okay, these 2 points as Tx and the Tx 2 prime, this minus the Tx and the Tx prime, because this is the 2 points BC and the BC prime will be here, all right. This can be given as this distance minus this distance, that is what it is written here. It is not complicated. So, if you can see them and correlate with this figure, you can find out that this is the way that we can actually go from one view to another view, all right, and correlate the angles, and finally, what we get is the tan I, this will be equal to sine of the gamma p, and the gamma p is here, all right. This is in the base plane, all right, and we have the tan of the alpha b, this is the ASA system, this is the ORS system, this is in ASA system, this is in ASA, and this is in the ORS system. So, you can see that this equation, which is nothing but geometrically obtained from all these views, okay, which are the combination of the ASA and the ORS system, you can actually correlate them here like this. So, if you know the alpha b and the alpha s, okay, and these two, then you can find out what will be the tool inclination angle and so on. So, similarly, for example, for tan of the alpha o, okay, which is given here orthogonal, from this geometry you can find out that the tan of alpha 0 can be equal to the sine gamma p tan alpha s cos of the gamma p and the tan of the alpha b. Again, similarly, as we have done it here in this case, we are actually converting, taking them from one plane to another plane, okay, and we are getting the final equation here. So, look at these equations carefully and correlate with these planes, okay. You can visualize this very well, it is simple geometry, okay, like I have explained in one of these. So, now we have discussed the three different systems in which the tool can be nomenclatured or tool angles can be defined, and these three systems are different. These three systems can be correlated. For example, here we have shown that ASA to ASA, ORS to ASA, and similarly we can convert from the ORS to the normal rake system, international system. Let us see here, this is a very interesting fact, like suppose we have the tool in the ORS system. Okay. So, this is the tool in the ORS system. So, therefore, this is the angle which will be orthogonal rake system. In the orthogonal rake system, orthogonal rake angle, and this will be the principal flank angle because the tool is in the ORS. Now, with this system, which is in the ORS Z0 and X0. Okay. With respect to this system of axis, we are inclining this Z0 at an angle of I, all right, and we are getting an axis which is Zn. So, Zn will be normal rake system pertaining to the normal rake system, because it is inclined to the ORS by an angle of I, that is the tool is inclined. All right. Now, if all these points we can project on this axis, for example, if this tool we will redraw in the normal rake system, this point we are projecting like this here and on the Zn axis, and then from here we are coming to the Z0 axis. So, this point is transferred from here to here. You understand how it is done. Once again, this is the tool which is in the ORS system. Now, this tool we will convert to the normal rake system. To convert that, we are making a system of axis which will be inclined by an angle of I. Therefore, this point can be projected to the Zn axis, and from Zn axis we are coming back to the ORS system Z0. So, this point is converted here. Then if you are joining this line, this point B0 and this point, let us say this is Qn, okay, then this angle that we are getting, so this will be the rake face, newly made rake face, okay, which will be in the normal rake system, because once again this is inclined. So, therefore, earlier we had this face which was the rake face for the ORS system, making an angle of orthogonal rake system with the x axis, x0 axis. Now, this angle, that is between the B0 Qn and the x axis, this angle will be the normal rake angle, because we have projected this tool to the normal rake system, that is the Zn, and this system is inclined to the Z0 by an angle of I. So, after we do that, then you use simple geometry, as we said that the principal cutting edge angle is 90 minus gamma s. So, then you take the tan of this alpha n, and by simple geometry you can find out that the tan of alpha n is equal to cos I and the tan of alpha 0. So, as you can see that this is in the normal rake system, whereas I and the alpha 0 they are in the ORS. So, therefore, this is a conversion from this is the normal, this is the orthogonal rake system, okay, the orthogonal rake angle. This is the tool inclination angle, and this is the normal rake angle. This is in the NRS, this is in the ORS. So, this is relating the NRS and the ORS system. Rest of the things we will discuss in the next class. Thank you very much.